An airplane flies towards 149 degrees at 525 kilometers per hour. What are the vertical towards 90 degrees and horizontal towards 180 degrees components of the plane's velocity? Okay, so let's just draw like kind of a standard grid here so we can get an idea of what these angles are going to look like. I can move this around a bit. Perfect. So 90 degrees is going to be our horizontal y-axis as we would imagine. And then, as they say, towards 180 degrees is going to be our x, and that's going to be in the negative x direction, right? Because over here will be positive x. So this plane is flying at about 149 degrees, which we'll just say is right here. And what 149 degrees essentially means is that this angle right here is 149 degrees. And if we know that all the way around is 180, then this angle is going to be 180 minus 149. So we'll call this angle theta, and it's going to be equal to 180 minus 149 degrees, just 31 degrees. Okay. So I always recommend just calculating what the smaller angle is going to be, because simply relying on your calculator to do sine or cos of 149, it can be a bit confusing with the negatives, and this way you just know for sure that you're getting the right positive or negative numbers. So now we have the angle there. Now the hypotenuse of this right triangle, we already know, right? It's 525 kilometers per hour. So we can actually treat this as a triangle, like I say, and use our trig ratios, cos and sine, to find the side length. So let's go ahead and find the horizontal first. Now we're going to use cos for that one because it relates the hypotenuse to the adjacent side. And the adjacent side is going to be this list right there. So cos theta is equal to adjacent over hypotenuse. And now we're going to multiply both sides by hypotenuse just to get the adjacent on its own, because that is what we're solving for. Cos theta equals A. Now our hypotenuse, like I say, is 525, and theta is 31. Now 525 of cos theta, that's going to give us 450. For our adjacent side, and that's going to be our horizontal component. However, there's one thing we need to think about, is we think about the units, right? So if this is pointing in the negative x direction and the positive y direction, we know the x component is going to be negative. So when we do this method of finding the small angle, make sure you think about, okay, is this a positive or a negative component? In this case, it's definitely negative. All right, so next we have sine theta equals opposite over hypotenuse, and this is going to give us our vertical. So again, same thing, solve for the opposite this time. And again, we're just plugging in the same numbers, but using this different sine ratio instead. So 525 sine of 31. And that's going to give us 270 equals our opposite. Okay, and this is our y component. And this time we think about it, and indeed the y component along the y-axis will be pointing in the positive y direction. So this is positive. Okay, so our x component, or our horizontal component, is equal to negative 450, and our y component, or vertical component, is positive 270. All right, so that's all for this one. Main takeaways are it's always a good idea to double check your angles and do it this way, just so you can make sure that you're getting the component in the right direction, right? Just double check, always think about where your resultant is and where those components would be, so you get your negatives right, because those can definitely throw off your answer. Okay, that's all for this one. I hope that helps. Thank you. Bye.